composition is different from the planet, then they likely formed in a different part of the solar system and are captured asteroids. You can follow the Martian Moon's exploration mission on our Twitter feed and website.
This is NASA TV.
Good morning, good afternoon, and good evening. I'm NASA's Gary Jordan. Thank you for joining us remotely for the next briefing in our series to preview the upcoming Crew-1 mission, the first crew rotation mission on a U.S. commercial spacecraft to the International Space Station for NASA and for SpaceX. This briefing will address the details of the Crew-1 mission and programmatic updates from NASA, SpaceX, and the Japan Aerospace Exploration Agency, JAXA. Joining our esteemed panel, based at NASA's Johnson Space Center in Houston, Texas, we have Steve Stitch, manager of NASA's Commercial Crew Program, Kenny Todd, deputy manager of the International Space Station Program, and Anthony Varya, lead flight director here in Houston for the Crew-1 mission. Representing SpaceX from Hawthorne, California, we welcome Benji Reed, Senior Director of Human Spaceflight Programs. And finally, we welcome Sakai Junichi, Manager of JAXA's International Space Station Program. We'll first start with some initial remarks from each of our briefers before opening it up for questions. We'll be taking questions on our phone bridge as well as on our social media platforms. If you're on the phone, please press *1 to add your name to our queue and to ask a question. If you're on social media, use the hashtag #AskNASA. We'll now begin with initial remarks from Steve Stitch.
Well, good morning. It's exciting to be here today representing the NASA team who has worked so hard to make this crewed rotation capability possible over the last 10 years or so. I started working commercial crew 10 years ago, and it's very exciting today to be here talking about our first crewed rotation mission, our first increment mission. You know, it's been a busy time frame for us in commercial crew working with our SpaceX colleagues. You know, we just landed the Demo 2 mission on August the 2nd, and so we've been looking through that data and reviewing that data in preparation to certify the vehicle for these increment missions and then also to get into Crew-1. We have baselined a new launch date recently. The new launch date will be October 31st at 2:40 a.m. Eastern, early in the morning on Halloween Day. We did that to give us a little bit more time to kind of work through a few things with the ISS program and also get ready for the flight. We'll dock about 25 hours later the next day, just like we did on the Demo 2 mission, and then we'll start this mission. The difference between this mission and Demo 2 is this is our first increment mission, so we plan to be docked for 6 months, and we have not taken that lightly. This is the first U.S. spacecraft to be docked that long. The previous record was back in Skylab, was about 84 days. We've improved the spacecraft from Demo 2. We have a better capability to land with some improved structural capability. We've improved the solar arrays to give us that full 210-day dock duration that we need for this mission. And we've made a few other improvements to the vehicle, such as having the capability to dock to the zenith port in addition to the forward port, and then also having port relocate. We also have been reviewing lessons learned from Demo 2. We've worked through a number of those. We had a number of observations and then a number of lessons learned. And then a couple of the big ones was talked about in the previous press conference. We had a little bit of erosion around an area called the compression pad or tension tie on the TPS. We've worked through that and installed some changes to the vehicle. Those are actually being installed over the last few days. We learned a lesson with the deploy of the drogue parachutes. It was a little lower than the nominal planned altitude, but within limits. We had a little bit of a venting clog, and we worked through that as well. And then, of course, everybody saw on landing for Demo 2, we had boats in the area, and we've worked with the Coast Guard to have additional assets in place to make sure that doesn't happen. So we're certainly excited to be here, certainly excited to have this Crew-1 mission and kick off our increment support for station. And I'll turn it over to Kenny Todd, Deputy Program Manager for the Space Station Program.
Well, thank you, Steve. And as one of the primary benefactors of this service, you can certainly add us to the long list of people who are very excited about this upcoming mission for the Crew-1 crew. It's going to be an exciting time on board the space station. Again, we're looking forward to getting up to 7 crew. We haven't been there in a while, so we're awfully excited about being able to get the crew size back up again. This particular briefing comes on the heels of our completion of our stage ops readiness review yesterday, which is a review that we hold within the station program before every crew flight and also before every cargo flight, just to make sure that we've got all our issues pounded flat and that we're ready to go and we understand what we're going to do with the mission and that the space station is ready to go and to receive that particular vehicle. We had a very good review yesterday. We had some forward work coming out of that, as Steve mentioned earlier. We made the decision, along with the commercial crew program, to move the flight a few days, allow us to continue to work through some issues on orbit with our crew time and trying to make sure that we get all the right boxes checked on board, as well as here on the ground before we get ready to welcome them on board. With regard to the current state of station, the increment crew on board, increment 63, with Anatoly, Ivan, and Chris Cassidy, they're doing fantastic. They're doing a great job taking care of station and continuing our science mission on board. As far as station goes, in very good shape. The only issue that I would bring up at this point is this little atmosphere leak that's proven to be a bit challenging over the last couple of months. But for those of you that follow station on orbit operations regularly, you'll know that we've been dealing with a small atmosphere leak over the last, well, really over a year. But we saw a little bump up in it here a couple of months ago. We did some isolation testing on orbit to try to find the source of the leak. We got a lot of good data out of that, and we were still parsing through that and trying to figure out what our next steps were when we saw yet another little tick up prior to last weekend. And so we decided to repeat that isolation test again. Again, got some very good data, and what we were able to confirm is that we didn't have a second leak anywhere else in the stack, that we were still probably just dealing with the initial leak, and for whatever reason we were seeing a little bit larger of a leak. So anyway, we were still trying to figure out the next plan after we finished this isolation test this past weekend, and overnight we were watching the leak rate overnight and saw that it ticked up again, and at that point we made the decision that it had gotten large enough that we felt like that we had a pretty good opportunity to get the crew up, start working through a more focused isolation procedure, trying to focus on some areas that we hadn't looked at as closely during the earlier test, just because those particular modules were hard to analyze, given that the crew was living there in those modules during those particular isolation tests. So we decided to go ahead and do wake the crew up. We went through a several-hour activity, and we think we got, again, some more data. We got a finer point on where we think the leak is, and module-wise, we at this point think it's in the Russian segment, in the service module area. Again, we're continuing to look at all the data from the test, but we do know and have confirmed with our Russian colleagues that we think there's something going on there, and so we're going to try to put a finer point on our troubleshooting plan. We have a leak detector on board, and now we'll start to really put some focus in the service module and try to work with our Russian colleagues to get that taken care of. So again, a lot going on board right now. Between now and Crew-1, we'll actually welcome the Northrop Grumman Cygnus module on board. It's launching later this week. We'll get to the International Space Station on Sunday. Got about 8,000 pounds of cargo, and roughly a third or more than a third of that is actually directly related to utilization of the space station. So we're very excited about that. The amount of utilization we're putting on these Cygnus vehicles now has gone way up, and so we'll have a lot for Chris to do, and we're looking forward to getting that module on board. A little later in the month of October, we'll do what we refer to as a Soyuz rotation. Kate Rubins and two of her Russian colleagues, both named Sergei, will be coming to the International Space Station, and they will take a handover from Chris and Anatoly and Ivan. They'll do about a 7-day handover between the 14th and the 21st, and then on the 21st, Chris, Ivan, and Anatoly will return to the Kazakh steppe back to Earth. So again, a lot going on in the early part of of October, which again helped feed this discussion about, where's the right place really to fly Crew-1 to make sure that we've got all the boxes checked and that we're ready to go. So once we get the Crew-1 crew on board, we'll be at a crew of 5 on the USOS. Between now and when this crew comes home, we've got a series of EVAs that we're going to do, probably around 4 EVAs. I anticipate we'll do those after the first of the year, just because of all of the associated cargo ops and the science with the NG-14 Cygnus module and the arrival in November of the SpaceX 21 Dragon cargo Dragon, which again will bring another several thousand pounds of cargo, over half of which will be directly utilization and science. So between now and the end of the year, we'll be doing a lot of science, a lot of vehicle processing. We'll turn the corner after the new year, do some EVAs early in the year, and then get ready for another Northrop Grumman Cygnus visit in February. And then shortly after that, we'll really get into the detailed plan with Steve and the commercial crew program about return of the Crew-1 capsule and making sure we got a good handover plan between Crew-1 and Crew-2. So that's how the increment's going to lay out. We're very excited about it. Again, count us as one of many that are excited about this upcoming mission. So we're ready to go.
Thank you, Kenny. We'll now hand it over to Anthony Varya.
All right, yeah, thank you, Kenny, and thank you, Steve. All of that excitement turns into exciting operations. And so as lead flight director for Crew-1 and one of the leads of the operations teams that keeps space station running and keeps getting ready for this Crew-1 mission and all these other missions, Northrop Grumman, et cetera, it is an extremely exciting time to be working in human spaceflight. And so the NASA and SpaceX operations teams are jointly getting ready for this launch that's coming up just outside of a month. We've got a few more procedures to polish. We've got a few more sims to finish out, but we are well attenuated to a 10/31 launch date and excited to see that go off early morning from Florida on Halloween. Soon we'll be putting Hopper, Shannon, Ike, and Soichi into quarantine, and they are getting ready to go here. They are certified as Dragon flyers by the SpaceX team, and they are ready to be increment crew members on board the International Space Station, and we're excited to see them up there. And so soon they'll be getting ready for going out to KSC, going out to Kennedy Space Center about 7 days before the launch, so that's looking to be at the end of October. But it's all about getting ready for these missions and making sure that the space station is also ready for those missions, and so that our teams are sitting over in Building 30 and Mission Control here in Houston and making sure that that vehicle is going to be ready so that when these people get up there, they can do all the good science that we want them to do.
Thank you, Anthony. We'll now hand it over to Benji Reed from SpaceX.
Hello. Hello. I'm very glad to be here today. It's always an honor to get to represent all of the many people here at SpaceX, our suppliers, and of course at NASA to represent these missions and talk about what's coming up and how important it is for the nation, for NASA, for our company, and really for humanity. Again, it's an honor, and with a lot of gratitude, we're here supporting these missions and these causes. This upcoming mission is, for me, really important, really special. I think it's true for a lot of us. This represents really the culmination of many years of work between the joint teams at NASA and SpaceX, putting together this whole commercial crew program overall, which has really been in the development and test stage all the way through now. And Demo 2 was a beautiful mission. It was just almost straight down the line in terms of the data that we got out of it versus the data that was predicted. We had some good lessons learned that Hans talked about earlier in the last press briefing, and also that Stitch has mentioned. And these are very important things. Every single mission we fly, we're going to learn lessons out of them and apply those to make each subsequent mission safer. But overall, again, that was fundamentally a test mission that happily we were able to extend and get a lot of good work out of that mission, and Bob and Doug were able to do a lot of work on station, because this is all leading up to the big operational cadence that we're about to move into. And this is super cool. Bottom line is that we are here to provide transportation services to help keep ISS staffed and to provide the cargo that ISS needs. Once we start with Crew-1, we'll be moving into a cadence where over the next 14 months, we will need to fly 7 Dragon missions. There'll be a number of crew missions, Crew-1, Crew-2, Crew-3, and ongoing. Our expectations are we'll be prepared to help NASA to hand off on orbit between all of those crews going from mission to mission to mission. At the same time, we'll be flying 4 cargo flights onto station is the plan, and we'll be ready to support NASA in that capacity as they need. And what this means for us as a company and also as a joint operations team between SpaceX and NASA is that starting with the Crew-1 flight, we will have a Dragon continuously on station again for the next 14 months. And every time there's a Dragon launch, there'll be 2 Dragons in space. So this really is a new era for us as a company, for SpaceX, and also for commercial space in general. This is a really exciting time that we're coming into. As we come into it, though, it's very important that we stay focused on the mission ahead. The next mission is always the most important mission. And of course, we understand the sacred honor that we have of holding the lives of the astronauts in our hands and making sure that they get to the space station safely, that they have a great and safe time on orbit for the next 6 months, that we provide lifeboat capability. The Dragon will be there in case they needed to come home early. And then, of course, when it's time at the end of their 6 months that they come home, and we bring them home safely and bring them back home to their families. And that's really what we're focusing on at the moment. As mentioned, we're going to be moving this flight to Halloween, to early in the morning on Halloween, on October 31st. As always, we are very happy to support NASA in the scheduling and the needs and be there for them when they're ready. And as a joint team, we fly when we're ready. We're staying focused now. We're taking the extra few days to continue our double and triple checks, make sure that we really have looked under every rock. We've checked under everything, right? Because most important is Mike and Victor and Shannon and Soichi, and making sure that they can do the work that they are very excited to do, the training, accomplish the training that they've just finished up and got certified with, and then bring them back home to continue their work as astronauts and also to be home with their families. So this is what we're focusing on now. Let's take a look right now at kind of what the mission will look like. I think we have an initial, one of our great drawings that give you a demonstration of what it looks like. As you can see here in this drawing, there's of course the launch and ascent with the F9 both stages and the Dragon attached. There's the separation of the first and second stages. The second stage goes on with its important mission of carrying Dragon into the right orbit before Dragon separates. At the same time, the first stage is doing its flip maneuver and entry burns and getting ready to come back home. Very important note here, our intention is to take this same Falcon 9, and after it comes back, we'll start getting it ready for its refurbishment to be flown on the Crew-2 mission. So at the same time, as I mentioned, the Dragon continues on. It separates from the Falcon 9 second stage and goes on into orbit. We go to the next drawing. We'll take a look here. And we can see now this is what we call the phasing part of the mission. So what we're doing is essentially chasing station in the most efficient way possible based on the orbital mechanics and where station is when we've launched, where Dragon is, and how do we get there in the best way possible using the right amount of fuel. And so we go through that phasing process, and then eventually we get there, we approach station, and we do our docking. As before, under Demo 2, the docking will be at the Node 2 forward port on Space Station. It will be an automated docking, and and of course, though, the crew does have the ability to go into a manual mode if they need to. And then if we go to the next line drawing, we can see what happens when it's time to come home. So we'll assume the crew's been up there for 6 months. They've done a lot of great work, a lot of great science and maintaining of the station. And then we'll do an undocking, again, automated, with the ability for the crew to do various things at different times in the mission if needed. Undocking, and then a phasing to come home, and then we come home. We basically do a re-entry burn and re-enter And just like on Demo 2, we'll be recovering the crew. We have a number of sites near Florida, both on the Atlantic side and the Gulf, and ready to recover the crew with our what we call our SpaceX Navy, with our recovery team and their vessels, and look forward to that happening. And that'll happen, like I said, about 6 months later, kind of in that March-April timeframe next year. So, you know, I mentioned a lot of the work that we do as a joint team to get us here. A lot of the effort between, you know, the beginning of this program and now was in the development, the partnership, and the certification. A ton of certification work that's happened to get us to be ready to go fly operationally. And this some examples of that kind of work that we do, right? We've done, you know, 500 hours of, or 500 tests, I mean, of you know, docking simulations down at Johnson Space Center. We've done over 8 million hours of hardware in the loop testing between our hardware systems and our software systems, including tests that basically simulate Dragon and Falcon working together, our systems working with NASA systems. On top of that, we've done thousands of hours of simulations with our operations teams here at SpaceX, our joint operations teams with NASA and with the crew. And we're at a point now, and as Kenny Todd mentioned, we finished this stage operations readiness review, so we're at a point now where we are we're in the final lane, and we're getting ready for this launch. I'd like to end here with an image of the crew here at SpaceX, and again, this is our focus. This is the most important thing. These great individuals who are going to be flying and running the first operational mission of Crew Dragon to Space Station, and I think it's appropriate as a good segue to mention that this will also be our first time, not only that we have 4 crew members on who stay on for 6 months, but will also be our first time we're flying an international partner astronaut. And you can see Soichi there on the right, and I believe we're going to be handing off to JAXA to speak next. So thank you very much to NASA, to JAXA, to all of the international partners, and of course to the American public for your trust in us here at SpaceX.
Thank you, Benji. For final remarks, we'll send it over to Mr. Sakai Junichi in Tsukuba, Japan.
Hi. Thank you for introducing me. And first of all, on behalf of JAXA, I would like to express my appreciation to all engineers and ground staffs who are engaged in this project, especially Space Exploration Technology Corporation, NASA, and the other cooperative companies for the launch related operations during COVID-19 situations. The success of Demonstration 2 mission was an epoch-making event of the commercial space development. Following it, a full-scale commercial flight will begin soon. This is not only a start of alternative human transportation system to the ISS, but also a start of a new era of LEO commercializations. I'm honored to be able to witness this event, and I'm proud that Japanese astronaut Dr. Noguchi is fulfilling his responsibility as a member of this event. Astronaut Noguchi has flown in space twice before, and he has always been challenging. Once again, he is gonna take on a big challenge of boarding a new spacecraft and his second long duration staying on ISS. I hope that he and 3 of his NASA astronaut colleagues will succeed in their mission. As reported earlier at the SOR held yesterday, with a new launch date and readiness review of stated that the human space activities will expand from ISS to LEO, the moon, and beyond in the future. We are looking forward to enjoying the beginning of our new LEO operations with ISS international partners during this period of change. Thank you.
Thanks to all of our briefers for those initial remarks. We'll now open it up for questions. Again, if you're on our phone bridge, please press *1 to submit a question. Once your name is called, please state to whom you'd like to direct your question. We'll have a lot of questions, so if you find that yours has already been answered, press *2 to withdraw it. On social media, please use the hashtag #AskNASA. Let's start on our phone bridge with Ceylin Barbauer from Gannett Publications.
Thank you. I believe my question is going to be addressed either to Steve or to Kenny. You so kindly alluded or said that there are planned EVAs after the first of the year. Can you share any of those details, please, of what those EVAs will entail, please, and who might be carrying those out?
Sure. As far as, let me start with the last question first. As of now, I don't know the crew complement. We usually, once we get a little closer in, we see how the crew tasking goes leading up to that time frame, and then we make the decision. We have multiple EVA qualified astronauts in this group that'll be on board, so that actually works to our advantage in making sure that we can optimize on all the work that we're trying to do on station, not just the EVAs. So, but anyway, so we'll sort that out as it gets a little closer to the end of the year and we start ramping up into that time frame when we're going to do them. As far as what we're going to do, it's actually kind of cool because again, it's an International Space Station, and a lot of times you'll hear us go out and work on something that's wholly a NASA product, but we're actually going to be doing some work on the Columbus module, the European Columbus module, and helping out. They launched a new platform last year, the Bartolomeo, and we were able to get it installed, but we haven't run all the power cables to actually make it functional at this point. So we're excited about the opportunity to get that platform up and running and totally functional, so that they can get some of their users and some of their customers on board as well. In addition, there is a Ka band antenna and a communication antenna upgrade that we're going to put on the Columbus. In addition to that, for our JAXA colleagues, they have their small fine arm. We're going to go out and do some work on it for them. In addition to that, some of our upgrades that we're doing on station over the next few months really focus on some new solar arrays. We're going to put some new solar arrays on. We're going to basically put them over the top of the ones that are there. Kind of a rollout solar array is what we call it. But we have to put some structures in place to be able to house those solar arrays when they come up about the middle of next year. And so we'll do those EVAs to install those structures to put us in a good position. So at a kind of a 5,000-foot level, those are the kinds of things we're going to be looking at. But again, the thing that when I look at that group of EVAs, is just the fact that we're doing things across the partnership to try to enhance everybody's position and things going on their particular part of station is pretty cool.
Next we have Bill Harwood from CBS News.
Yeah, hey, I think this is a question for Benji. I know the Demo 2 vehicle, obviously the lessons learned, we've heard about that, but can you talk a little bit about what's required to refurb that vehicle to get it ready for flight? What has to be done to get everybody happy that it's good to go again? And just given the environments the vehicle flew through, I mean, it seems like that'd be a pretty good challenge. I mean, you got heating, you got water and all that. Could you just talk about how that will play out? Thanks.
Absolutely, that's a great question. We've designed Dragon from the get-go, even Dragon 1, to be able to re-enter, right, and to come back and keep everything inside safe. On the Dragon 1s, it was cargo. On Dragon 2s, it's crew and cargo. And so in terms of the re-entry heating that you mentioned, you have to be not only keeping it safe, but plenty of margin against that. Very important. And so the good news is that there's not a lot that you have to do to go and say refurb a lot of the thermal protection system, the TPS, and that sort of thing. There is work that we do. We do inspect it very closely. We check it out very closely. We do various touch-ups, and then there are aspects of things that we do replace for sure. But one of the goals, for example, like a heat shield, is that you want to be able to reuse it. That was also part of the design from the get-go. Another question we often get, you mentioned, is we splash down into salt water. Isn't that really hard on things? And it is. Salt water can be a very difficult environment to be in. It can be very corrosive. It can cause a lot of long-term problems if you're not prepared for it, if you haven't designed for it. The great thing about having run so many missions with the Dragon 1 program, with cargo, which was a fantastic program, it has allowed us to learn a lot and develop even more how to do reuse, how to be able to reuse Dragons, which we've reused many Dragons on the cargo Crew-1, the cargo Dragon 1 program. We've reused many Dragons, and so we've applied all of that wisdom and all of that knowledge to how we are going to maintain the Dragon 2s for crew and for cargo going forward. In terms of the actual work that we do, first and foremost, it's inspections and assessing the data, analyzing the data. So we spend immediately, even once we launch, there's some initial inspections. There's some work that's done on station. We've looked at all of the data from the launch aspects of the Dragon, anything that it might have seen or any other data that we saw. And then there's some pre-undocking imagery that we do, that we work with NASA on. We review that, we inspect that closely, and then coming home, we're getting lots of data, and as soon as we splash down, the teams are already analyzing all of the data that came in. That's a very, very important piece. We want to listen to the data, we want to understand what the data is telling us, and let's look for anything that looks out of the ordinary, look for anything that's trending differently, and then we can go in and start to really figure out what we might need to go fix, if anything. And then, of course, there's the inspections. Once you have the capsule on the ground, you can start to go through it, and then we start to take aspects of it apart so that you can inspect more deeply. Right? We take the panels off, we look inside, we get in there. There are items that we replace. Various components or subsystems that are appropriate to replace because they have a limited life, or they've used up a certain amount of their consumable. Other things we may decide, well, you know what, this one we feel like the data, or for some other reason we need to replace it, so our team's ready to go. One of the big things that SpaceX has been doing in the last number of years as part of coming into the Dragon 2 programs for crew and cargo is establishing a very effective refurb and really overall process and facility down at the Cape. Our goal was to be able to come in and do all of Dragon processing at the Cape. And we, again, the Dragon 1 program, that cargo program, allowed us to do a lot of that work and start to develop what that process looks like, what the resources and tools are that we need to do that. And we have since established a great facility and a great team, most importantly, with a lot of knowledge and skills that are down there that are ready to just continue to work our Dragons, right? They've already been down there. They do a lot of the closeouts and pre-flight work between the time that the Dragon ships out of Hawthorne and gets to the Cape. They do a lot of that work during that time after it's at the Cape. They've already been able to run multiple Dragons through there. At the same time, they're going to be able to do lots of refurbishment and have Dragons coming back. So they expect to be able to see, every once in a while, new Dragons show up, lots of Dragons coming in for reuse, and then going through that whole refurbishment process right down there at that whole facility, which is really exciting. So we're going to have we already have a whole Dragon production and refurbishment and test facility set up down there. When you go through all of the steps and you've applied all of these lessons after the last many years and all of these missions that we've done, it actually makes the process, I won't say easy, because spaceflight is hard and a lot of what we do takes a lot of attention and work, but it makes it smooth. We know what we need to do. We have the awesome team to go get it done, and then we go through and get the refurbishment done.
Next, we have Douglas Messier from Parabolic Arc.
Yes, I was hoping that one of you guys could talk a little bit more about the heat shield issue. Now, there do the connections stick out and they burn off, or how does that work with the tile, and exactly what happened on this flight, this most recent flight? Thank you.
Yeah, I guess I'll take that one. Most capsules for entry, you have to separate, in SpaceX's case, the Dragon, the trunk. And there are some bolts that protrude out once that trunk separates on orbit and the vehicle comes back in. It's the same design on Orion and other spacecraft. And so that area around these tension ties is a very complex flow field. And so basically on Demo 2, what happened is in this complex flow field, there was some erosion of some material between tiles that we saw on this flight. In that same area, for whatever reason, in this complex flow field in Demo 1, we did not see that. So we didn't find this out until after landing, when the vehicle was inspected. So what we've done is we've gone in and changed out a lot of the materials to better materials. We've made this area robust. We've made the area in between these tiles better. We have a better process for installation. We took those design changes and we tested that in the same facility out at Ames that we've used for a space shuttle and other programs. It's called an ArcJet, and it's able to simulate that entry environment. And so we took 5 different samples and we sent them out to the Ames ArcJet. We exposed them to the reentry environment. We exposed them also to an abort environment. So during ascent, if we were to execute an escape where Dragon separates from F9, those entries for some cases are a little bit more aggressive than the nominal end emission. So we went through and tested these changes, and the changes performed very well. We've done analysis on the changes, and so we're very pleased with what we have for Crew-1, and likely the configuration will fly for many more flights.
Next we have Eric Berger from Ars Technica.
Yeah, hi. Good afternoon. My question is about weather, probably for Anthony. We had a lot of constraints in the launch and the landing for the Demo 2 mission, and it seems to me like we got fairly lucky with both the launch and the landing happening relatively on schedule. And I'm just wondering, have either of those been relaxed for launch or landing, or are there changes to the rocket or the spacecraft that maybe give you a little more flexibility in terms of when you can go and when you can come back? Thank you.
So that's a great question. Yes, we have re-looked at the weather rules that we fly by, and we're finishing those up and getting those ready for flight later in October. But the big changes are kind of going to be, I'd say, transparent in the launch side of things, just in how we determine when we're ready to go. Because we're not just looking at what is the weather at the launch site. We're looking at the weather the whole way, as we say, uphill, the whole way up the eastern seaboard, looking at a kind of probabilistically, where are the places where if there was an abort, you'd be most likely to come down, and what's the weather in those spots? So how we look at those spots and how we determine that overall the picture is good enough that we can go, or that we can not go, or that we at least need to talk about it, that's something that we're refining based on lessons we learned from the Demo 2 mission. I'd say on the back end of flight, we are in a better position because of upgrades to the hardware. We've got new, what we call back shells on this SpaceX Dragon that will allow us to come down in a little bit rougher wind, a little bit higher, and so that's going to increase our capability that on a given undock date, we can find the day, we can look at the weather and decide it's a good time to come home. I'd say that our chances at the end of Demo 2 were probably 1 in 7. We got it right on the first try, and our chances are even better, probably 1 in 4 at the end of the Crew-1 mission.
Next we have Robert Perlman from Collect Space.
Hi, thank you. A question, I think, for Kenny, and then a question for Benji. First, for Kenny, this is not the first time there will be 7 crew members or more on board the space station, but it's the first time you're adding an expedition member. There's only 6 sleep stations on board. Can you talk a little bit about when the 7th sleep station will be added and how it was decided who will be the odd person out on this crew? And for Benji, if there's a story behind it, how did you arrive at the title Crew for these missions, Crew-1? I know it's kind of obvious, but were there other contenders?
Let's see, Robert. That's a good question. Yes, we clearly have more crew than we have sleep stations, and that's something we're looking at in terms of how we do this going forward. The reality is that when we have 4 USOS crew members on board, then we have an adequate number of sleep stations, which if you look at the rest of the program and how we have it laid out, once we get our agreement on how we're going to fly on each other's vehicles, how we're going to continue to make sure that we have a good coverage on station. Our intent is to be at the 4 crew on the USOS. And so, again, when we think about a 5th crew member, that's probably not a steady state type of operation we'll be in. But that said, we know that there's a possibility we're going to be here going forward, at least in the near term. And so we are looking at options for where we could put another temporary sleep station that could be a little more, it won't be exactly like the current crew quarters, but it'll be something similar in terms of privacy and being in a rack location. We've identified a couple of places on station. We're currently working throughout the partnership to talk about those options and to assess them, but clearly not going to be in place for this particular near-term time when we're going to have 5 USOS crew on board. But we're working to solve that problem, and this time around the crew has worked closely with us, and the crew office in general has worked with us very well to help get us in a good situation where we've got a plan for this particular 5 USOS crew period.
And I can answer the naming question. I think that number one thing with naming is that it should be inspirational, and it should be simple, and it should be memorable and usable if you have to use it, in day-to-day work or operations. We always refer to this program as the NASA Crew program here, and so these missions are the NASA Crew missions. And since this is the first operational mission, it's the NASA Crew-1, and I think it says it all. I don't, it doesn't need any kind of acronym or anything else. It's just cool. This is the first operational mission that we're sending crew up in.
Next we have Megan Bartell from space.com.
Hey, thanks for taking my question. This is based on something Anthony said, but I don't know if either Kenny or Steve would like to weigh in as well. You mentioned that the 4 crew members will be going into quarantine soon, and I was hoping you could talk a little bit more about that, and particularly say how long before launch they'll be going into quarantine, whether they'll have the option to quarantine at home like Bob and Doug did earlier this year, and any ways that the process is being affected by COVID, or sort of how it would compare to the standard procedure that I assume you folks have developed for the crew flights. And then also sort of talking through the pre-launch activities and how that plays in terms of whether there are any rehearsals or similar. Thanks.
For DM2, for the Demo 2 mission, what we did with Bob and Doug, we put them in a sort of a soft quarantine, which looked a lot like what all of us really should be under per CDC guidelines, and we kind of strengthened that quarantine as time went on.
We'll do a static fire of the rocket, the first stage, to make sure all the 9 engines are working and the rocket's functional. And then the very next day, we'll take the crew out and do basically an end-to-end dress rehearsal for the launch. They'll start in crew quarters, put their suits on, be transported out to the launch pad 39A, go up the elevator, and then the closeout crew from SpaceX will put them in the vehicle, and then we'll run through that whole timeline just like we would on launch day. So it's very similar to what we did on the Demo 2 mission.
We'll now go over to some social media questions using the hashtag AskNASA. The first comes from both David and from Splat, asking about the ports on the International Space Station. So this one can go to Kenny. If you can describe where Crew-1 will dock and how it will work with CRS-21 and the Boeing Starliner.
Sure. First of all, when Crew-1 arrives to station, it will arrive and dock at the forward, what we call the forward end of station. So it'll be in the Node 2 forward location. So it'll be right out on the front of station. SpaceX 21 that comes up later in the year in November, it will come to the Node-2 Zenith port. So basically, you'll have the Crew Dragon on the front. You'll have the Cargo Dragon sitting on top of station. We have a plan right now. If indeed the Boeing Starliner flies later this year, we'll have a plan for doing what we refer to as a port relocation. The SpaceX 21 mission, once it gets on, it'll be on for roughly 35 days. At that point, we'll undock that particular Cargo Dragon. It will come home. It will free up the Node-2 Zenith port, and then, as I alluded to, we will put the crew in the capsule and we'll do a port relocation and allow the Crew Dragon basically to maneuver up to the Zenith port, and then that would then provide a home for the Starliner vehicle to come up and dock.
And we'll take one more question on social media. This one's from Jasu on Twitter, and this one's for Steve. Why is the Crew-1 mission going to take 25 hours to dock to the space station?
Yeah, that's a good question. So what we've done with the Crew-1 mission is we've sort of laid out a timeline every day to make the docking opportunities and the crew sleep predictable. And so the best balance was to have that 25 hours. It just turns out the way orbital mechanics works, it takes about 25 hours or so to get there for that particular day. And we've done that for a couple days in a row, where we'll sort of slow down how fast we get to the station, keep the station and the crew sleeps the same, and then we'll dock about 25 hours after launch.
We'll now go back to the phone bridge, starting with Jeff Faust from Space News.
Hi, a question for Benji Reed. You mentioned earlier you're planning 7 total Dragon missions, crew and cargo, over the next 14 months. Given your plans for reuse, how many individual Dragon spacecraft do you anticipate needing to fly those 7 missions? And does that total also include any additional private missions, such as some of the private astronaut missions that have been discussed recently? Thanks.
Hi, Jeff. That's a great question. And I actually don't have the exact number, but I know we can get it for you. I'd have to think real quick and do math in my head publicly, which is dangerous. But a number of those are reuse flights, and a handful of them are new. So, for example, as we already know, the Crew-1 capsule is going to be refurbished. I'm sorry, the Demo 2 capsule is already being refurbished for Crew-2. And we're looking at the Crew-3 capsule as well as possibly being a new capsule. But what we're assessing right now is the right way to do all of those in the most efficient manner we can. Make sure that we have the right amount of margin to schedule between refurbishment and need for flight. And then so to give you the exact number, I'd have to get that for you. But more importantly, the real question is about that schedule margin. In terms of the private mission, that doesn't include private mission planning. That's just for what we're doing for NASA. And so we are excited to look forward to the opportunities to do private missions. I think that late next year is a good time to start looking towards, when we hopefully could start those missions up. We're working with a number of partners that we have in the commercial passenger area. As you know, you've already heard of Axiom and Space Adventures have got some different opportunities that they're working and that we're partnering with them on, and that's very exciting. And so we look forward to be able to provide transportation services for lots of different partners, and also be able to continue to support space station directly with commercial passengers as needed. And then beyond that, long term, we see the Starship opportunities, and we already have another Japanese person who will be joining us in the future, Mizawa-san, for a lunar orbit mission as well on Starship. So these are kind of all these exciting things that we look forward to. But yes, we would also are looking to how can we do a commercial mission, probably towards the end of next year.
Next, we have Dave Mosier from Business Insider.
This is for Kenny or whomever is best. How much of a factor is this pesky air leak in Bethesda in terms of launch dates? In other words, if you can't locate and fix it soon, could that push back or move Soyuz and Crew-1 flight dates? And then also, what do you expect a fix to look like for that leak at this point? Thanks.
Well, in terms of how it might affect our upcoming plans for our flight program for crewed flights or even cargo flights, at this point, we're working the problem. Yesterday, we had an extensive conversation at our ops readiness review, and out of that, we basically put a plan in place that says we're going to continue to troubleshoot this problem. In parallel with that, we're also going to go look at our flight manifest, all of our cargo flights, all of our crew flights, and see if we can get to a plan that says if we continue with the leak at the same rate, how far could we continue to provide the necessary consumables through our cargo flights to continue to keep us sustained infinitely. But the bottom line is, based on where the leak rate is today, and we're going to fly a couple of resupply tanks on the upcoming flight this week on the Cygnus flight, we'll be okay out into the spring of next year. So this is not necessarily a near-term problem as long as the leak rate stays at where it's at today. But if it were to get worse, obviously we'll circle back up and revisit that. But as we get closer to every one of our flights going to the International Space Station, if this problem continues, and then we will constantly be looking at our consumables, be looking at our logistics train, and making sure that we can stay ahead of it. But first and foremost, our goal is to find the leak. And you asked about the fix. The fix is really going to be based on what we find once we get eyes on the actual leak itself. When you look at a vehicle the size of the space station, it's got valves that go to vacuum. It's got lots of different lines, plumbing. It's got windows with seals on them. So there's a lot of acreage with a lot of different I'll say leak paths that could be potential spots for us. And so the good news is that we've at least I tell people, now instead of a bunch of haystacks, we're down to maybe just one haystack, but it's still a needle we're looking for. We've got capabilities on board with our leak detector to go do some fine checks now, and that's the next steps that we're heading down. And so working very closely with our Russian colleagues, and again, our primary goal is to find this leak in the near term and get it taken care of.
Next we have Mark Carreau from Aviation Week.
Questions for Kenny Todd. Just checking back and clarifying, I think, on the number of crew going forward that the station can house. When was the last time you had as many as 7? And is the objective, at least from the NASA perspective, to have 7 total, but 4 to 5 on the U.S. side, if possible, depending on how many the Russians can fly at one time?
Correct, Mark. Starting, and I'm thinking on your first question, by the way, but on your second one, yeah, the goal was to have 4 on the USOS, and then obviously three on the Russian segment. So yeah, steady state. We're considering a 7 crew is pretty much our steady state going forward. And again, the crew makeups we will continue to evolve as we work with our partners to kind of manage the vehicle traffic going back and forth to station. So you might have periods there where you'll have a couple of vehicles, and for a week or two you might have even a larger crew than 7 during some handover periods. But the steady state crew size will be 7. As far as the last time we had 7, I was trying to think of it here, Mark. I can't think of it off the top of my head, but I will find out, and I will make sure we get that data to you. But yeah, it's been a little bit.
Next we have Paul Rivera from WESH TV in Orlando.
Hey, thanks for taking my question. This is a follow-up to the first question about the EVAs to whomever wants to pick up on it. But you mentioned that they're going to be, EVAs aside, conducting science once they get up there. I was wondering if you all could speak specifically to what they will be accomplishing once they arrive at the space station and start to live there.
Can I ask a clarifying question? Were you asking about the EVAs in science or just science in general? Inside.
And Kenny, I believe it was EVAs associated with science.
Yes, from the standpoint of what we're doing with the EVAs is we're enabling enabling science. The Bartolomeo platform that our ESA colleagues flew last year on the SpaceX Dragon, that particular platform is intended to house experiments, commercial experiments through their own customer front door that they have within ESA. And so the EVAs are really going to be helping to establish that capability for our ESA colleagues and giving them that platform to be able to basically offer that to commercial use as a science platform. And so that's going to be our probably one of our primary science objectives when it comes to EVAs this coming January.
We have time for one or two more questions, so we'll hand it over to Susie Nielsen from Business Insider.
Thank you. This question is for whomever is best to answer it. So after the ISS had to maneuver away from some space debris last week, NASA Administrator Jim Bridenstine said that the station has maneuvered 3 times in 2020 to avoid debris, and in the last 2 weeks there have been 3 high concern potential conjunctions. So how concerned are officials about space debris over the next few months, and have you done any preparation for a potential space debris incident?
Well, I mean, space station's been flying on orbit for 20 years now. The debris is not a new thing for us. It's been around for a very long time. What we've seen over the 20 years is that we're getting more and more debris. We have some pretty good capabilities to track debris. We work closely with the team that does that. But again, debris in space is just a reality, and we live with it every day. We count on our tools and our processes and the people that help to monitor those items that we know about. But as we continue as a world population to launch more things into orbit, then you know that just creates additional debris that programs like the space station will have to not only acknowledge but have a plan for. So the way that we deal with it is, again, we try to track it. There are folks out there who catalog these things and then basically watch them 24 hours a day, 7 days a week. And when one of these items looks like it's on a trajectory to pass through the space station trajectory, then that's when we get involved. We have a group here that specifically does the probabilistic assessment for those pieces of debris and the potential for hitting the station, and then we have rules in place that tell us when we need to do the maneuvers. But the idea of worrying about debris is something that has been in the program since day one, and again, it's just become more and more of a watch item and a concern for us as we've watched low Earth orbit become a little more cluttered, and we're just counting on our processes and having a station that with propulsive capability that we can get away from some of these items that might otherwise hurt us.
Thanks to all who submitted questions, and thanks to today's briefers for taking the time to discuss the Crew-1 mission. We have one more briefing coming up today. We'll be hosting the astronauts of Crew-1 for a news conference at 2 p.m. Eastern Time. For details on this briefing and for the latest on this mission, please visit nasa.gov/commercial crew. Thanks again for joining us. That will wrap up today's Crew-1 mission overview briefing.